Hey guys, this is Fraser from Expand Tutoring. Today we're going to be looking at this 4-mark, specifically HL question, because it uses some content that only HL students take a look at, which is proof by contradiction to be exact. So we're using the method of contradiction in order to prove that root 3 is irrational. So probably you guys have seen the proof for root 2 being irrational. It's a very similar argument. So the way with contradiction works is what we're trying to prove is the statement that root 3 is irrational. So what we do in contradiction is we assume our statement to be false. That means that root 3 is rational. What does it mean to be rational? That means that root 3, so I guess actually technically we should say assume root 3 is rational, right? Assume that the statement is false. This means that root 3 is equal to some p over q, where p, q are elements of the integers, and p and q have no common factors. So that means that we can square both sides, right? 3 is equal to p squared over q squared. So if we just move q squared over, that means that 3q squared equals p squared. So this means that p squared is some multiple of 3. That means p squared is some multiple of 3. This means, right, it's a multiple of 3 because we've written it as 3 times some integer. This means that p is a multiple of 3. So this is something you guys also have to know, that if a number n squared is, like, let's say odd or even, or n squared is a multiple of 3 in this case, that means that the number n is also a multiple of 3. This we can assume, we don't have to prove this. So if p is a multiple of 3, that means p is equal to 3n, where n is some integer. That means that we can substitute that in, so 3q squared is going to be 3n all squared, so that's 9n squared. So q squared is equal to 3n squared. So similar logic. Therefore, q squared is now a multiple of 3. Is a multiple of 3, which means q is a multiple of 3. So there's actually quite a lot multiple of 3. There's quite a lot of writing with proof, and you have to be you can't like rush the writing. So that means that p is a multiple of 3, q is a multiple of 3, and we've reached our contradiction. This is a contradiction. Because we assumed at the beginning that because they're rational, that means that they have no common factors. But if they both are multiples of 3, that means that we could write, for example, we've already reached our contradiction, but just to make it explicit, q is equal to 3m. But that means that p over q is equal to 3n over 3m. So we can simplify it, and we can do that infinitely many times. But I think the cleaner way to do this, I'll leave that there, the cleaner way to do this is to say that they're both multiples of 3, and we assume them to be co-prime, to have no more common factors. So we've reached our contradiction, and therefore, by contradiction, we know that root 3 must be irrational. Okay, so hopefully that was clear. I'll probably be doing a couple more videos on proof, because proof is difficult. It's a difficult topic. It's only for, there are some more simple algebraic proofs for SL, but for HL, you have induction, you have contradiction, counterexample. So we're making more of these. Let me know if there are any other questions you guys want to see. And of course, as always, if you feel like you could do with a bit more tutoring, a bit more one-on-one tutoring, feel free to head over to ThinkSmart Tutoring. The link for the website, for the international and Dutch website, is in the description below. You can grab a tutor there. You can check the subjects that we tutor in: maths, chemistry, physics, among others. So yeah, it's very flexible. If you sign up, you can pick when you want to do lessons, how frequently, for how long. Obviously, the tutors have recommendations because of their experience, but ultimately it's down to the student. And yeah, we make more of these videos. So see you guys soon.